Okay, here I'm gonna have two problems that I want to use where we will use polynomial long division. Okay, so I have 2x squared plus 5x plus 7 divided by x minus 3. We want to use this because later on when we have partial fraction decomposition in calculus 2, this types of problems and knowing how to do these type of problems help simplify our problems a lot down the road. So first, we would like to say 2x squared plus 5x plus 7, and this is divided by x minus 3. So first, x will go into 2x squared, 2x times. 2x times x is 2x squared, and now 2x times negative 3 is negative 6x. So what we do, we draw the line. Every time we draw the line, we change the sign. So this turns into a negative number, and this negative turns into a positive number. We know we're doing it correctly because the first numbers will always cancel themselves out. So now we say 5x plus 6x is 11x, and we drop the 7. Now, x will go into 11x 11 times. 11 times x is 11x. 11x times a negative 3 will give us negative 33. Once again, we draw the line. And I'm putting this in red so it'll stand out. Every time we draw the line, we change the sign to sum it up. So that's going to make this positive x, 11x into a negative, and it's going to make this negative 33 into a positive. So we continue with it, and from here we say 7 plus 33 gives us 40. Now x will not go into 40, so since it will not go into 40, we know that this is our remainder. We can either put that as remainder 40 or remainder 40 over x minus 3. Now, over here on this problem, we just want to go over something that's an easy mistake to make. We have 3x cubed plus 5x plus 9 divided by x plus 2. But one thing that we want to make up, if we notice we are missing an x squared term. So anytime we're missing an x squared term, we want to keep the proper spacing and integrity of the problem. We want to put in 0x squared. We use that simply as a placeholder. Okay, it keeps the integrity of the problem. So now we have x will go into 3x cubed, 3x squared times 3x squared times x is 3x cubed. 3x squared times 2 is 6x squared. We draw the line. We're going to still put this in red because I want to make sure that it stands out. We draw the line, we change the sign. 0x squared minus 6x squared is negative 6x squared. We drop the 5x as we did in traditional division. X will go into negative 6x squared times, that's negative 6x. Negative 6x times x is negative 6x squared. Negative 6x times 2 is negative 12x. We draw the line. We change the sign. So that makes both of these negative numbers into positives. It's going to always cancel out. And we draw it so we can keep the rhythm of it. 5x plus 12x is 17x plus 9. We're closing. X will go into 17x 17 times. 17 times x is 17x. And 17 times 2 gives us a 34. And for the last time, we draw the line. We change the sign. And now, y'all, we have 9 minus 34. So yeah, this is going to give us a negative 25. X will not go into negative 25, so our remainder is negative 25. These are just two quick examples of how we use polynomial long division. We use them in pre-calculus algebra, but we use them a lot more once we get to calculus 2 down the road, particularly certain problems that have where we have to use partial fraction decomposition.